So this exercise is related to topic work, energy, and the power. You will find a similarity whenever you're solving such questions. You will find the similar pattern is there for these questions. So in the first one, define power. How we define the power? The definition of a power, it's a rate of energy transfer or rate of work done or how much work is done in a unit time. That is known as a power. When you use the term rate, then you don't, it's obviously related to time. So rate of work done, rate of energy transfer, work done in a unit time. Use the definition of the power. Show that the SI base unit of the power is kilogram meter square second raised to power negative 3. So when you write, whenever you want to write the base unit, first thing you always write a formula for that quantity. Any formula you remember, like let's say you remember a power formula, force into velocity. So you can write that as well. If another student remember a power formula that power is energy over time. That's also fine. Another student remember power is work divided by time. That's also fine. Any formula you remember, you use that to work out. So if I remember power is a product of force and velocity, force is Newton, but Newton is not the base unit. The base unit is kilogram, meter, second raised to power minus 2. And what about the velocity? It is meter per second ms minus 1. So when you simplify, it will be kilogram meter square second raised to power minus 3. So that will be the base unit. So not frequency into velocity. Power is a product of force into velocity. This is not frequency, it's a force. Another formula for power, if you remember, work over time. And power, work is force into distance divided by time. And the base unit of the force, it is kilogram meter second raised to power minus 2. Distance is meter and time is second. So when you simplify this, you'll get the same result as kilogram meter square second raised to power negative 3. So it does not make difference that any formula will work if the right formula will work. If you write anything, it's not like it will work. It's the formula should be correct. The intensity of a sound wave moving through a gas is given by a formula that I equals F square A square Vk, where F is a frequency, A is the amplitude, V is the speed of the wave, K is a constant that depends on the gas. Determine the base unit of K. So if we want to determine the base unit of the K, first thing, when we work out, we have to write like what is the concept of an intensity? Intensity is power in a unit area. Like so intensity, we have this formula I is equals to F square A square Vk. What is intensity? Intensity is power acting on unit area. So it will be F square A square V into K. What about the unit of the power? Power itself, we just wrote the base unit previously. It was kilogram meter square second raised to power minus 3. I can separately work out the base unit of intensity here. Like I know the intensity is power on unit area. So power, we know that it is kilogram meter square second raised to power negative 3. And, and the area is meter square. So meter square will cancel with meter square. So the base unit of intensity will be uh, kilogram second raised to power negative 3. So base unit is kilogram second raised to power minus 3. Frequency is a reciprocal of the time period. So it is 1 over second or second inverse. So it will be second minus 2. Second minus 1 is there, but because it's a square, that's why I said minus 2. Amplitude, the distance, so it will be meter square. And speed is ms minus 1. And then k. So this will become kilogram s minus 3, s minus 2, m square, m to m square, and into ms minus 1. Now, see, s minus 3 is there, and this is also minus 1 and minus 2, so s minus 3. So these will cancel out with each other. So what we are left with, we are left with kilogram here, and we're left with meter cube, and then K. Meter cube is the other side will be divided, so kilogram divided by meter cube, so that is K. Or we can say kilogram m meter raised to power minus 3. So kilogram per meter cube, what is this kilogram per meter cube? Actually, this is a quantity which is known as density. So here, because density is mass in a unit volume. So here actually what is this K? This K is the density. So actual equation was I is equals to F square A square V into rho. That was actual equation. But they changed this rho into K. Again, another question, define power. So how we define the term power? Power is rate of work done or work done in a unit time. We can define that as a power or say that as a power. The next is mechanical power can be calculated by using a formula P equals F into V. Use the concept of a work and the definition of a power, how this formula is derived. So the short derivations are there in paper exam, and it's there for both Edexcel and for Cambridge student. So the short derivations are there. Even like sometimes they ask derive an equation for the resistance of the component in series or in parallel. So we have the formula that the power is equals to work divided by time. What is work? Work is force into distance. So force into distance divided by time. And what is distance divided by time? It is velocity. So we can say power is a product of force and velocity. So P is equals to F into V. The engine of the lorry provide 130 kilowatt of a power to a lorry wheels when it is traveling at a constant speed of 25 along a straight horizontal road. Show that the resistive force opposing the forward motion is about 5,200 newtons. Look, if it is moving at a constant speed, when something move at a constant speed, so the driving force will be equals to resistive force. So we will find that because the product of force and velocity will find the power. Like, I mean, we have the power and we know the velocity, so we can find the force. And because it is moving at a constant speed, so this force, which is a driving force, will be equals to the resistive force as it is moving at a constant speed. So we just have to take a ratio power divided by velocity will give us the force. So power is 130 watt and the velocity is 25. So what's the answer here? 130,000 divided by 25. It will be about 520. 130,000 divided by 25. 5,200. Okay, exactly. Okay. So 5,200 and the unit should be Newton because it's a force. The next is a lorry in B travel at a straight section of a road that is inclined at an angle theta. The lorry has a mass m and the weight acceleration due to gravity is g. Determine the expression in terms of m, g, and theta, the component of the weight which is parallel. So on inclined surface, remember whenever object is on inclined surface, two components are there. If its weight is acting downward, and we take the axis like this, so the angle here will be same as angle here. So this will be W. The component of the weight which is with an angle, this will be W cosine theta, which is perpendicular to the inclined surface, and the component the weight which is parallel to the plane, that is W sine theta. So this is on inclined surface. We discussed the topic inclined surface. The green line is representing the plane. Like whenever you have anything on inclined surface, there are two components of the weight are there. So this is an inclined surface And here we have the lorry. So weight of the lorry is acting downward, the gravitational pull. This weight we resolve into component by taking an axis. So here angle theta. So when we take an axis here, when we take the axis, so the angle here theta will be same as angle of the inclined surface. So weight will have the two component. One of the component is with an angle, another in opposite to the angle. So the component of the weight which is with an angle, that is W cosine theta. So W cosine theta is acting in this direction. And the component which is opposite to the angle, that is W sine theta, and that is also parallel to the plane. So we want to determine the expression of the component of a weight that acts parallel. So that is W sine theta and W is mg. So we can say mg sine theta. So it's always the case that the parallel component is W sine and the perpendicular component is W cosine. The total resistive force remain unchanged, which is 5,200 Newton. The engine now provides a greater power to maintain the speed at 25. The total mass of a lorry is 36,000 at an angle of 1.4. Determine the power now provided to the engine. Look, first, when the lorry was moving, it was moving on the horizontal surface. So when it was moving on the horizontal surface, so in that case, the resistive force was not like say the forward force is there, balances with a resistive force of 5,200 Newton. So the driving force was also 5,200 Newton. And we have the product power is equals to the product of force and velocity. So we have the velocity 25 and we have the force, we got the power of the engine. Now what happened? Because it has to move against its weight as well. Because there's a component of the weight, there's a resistive force of 5,200 Newton, and there's also a component of the weight which is parallel, that is W sine theta, that is also opposing. So the forward force to maintain a constant speed of 25, so the forward force should be the sum of 5,200 plus W sine theta. So if the forward force increases, to maintain a same constant speed, the power will also increase. So first what we will do, we'll find the new force, which will be the sum of the resistive force plus the component of the weight. So the resistive force is 5,200 and the component of the weight is W, which is mass 36,000, 9.8 the gravity, sine, and the angle is 1.4. So this is the component of the weight and this is a resistive force. So the total force which it need will be the sum because it has to maintain a constant speed. To maintain a constant speed, the forward force must balance with a back resistive force or a backward force. So when we sum this, we got 13,800 Newton is a total force which we need. So now if the 13,800 Newton is a total force, what power for the same speed? So power is a product of force and speed. The force is 13,800 times the speed is 25. How much power it has to need to? So it will be 350 into 10 to the power 3, 350,000. Okay, 350,000, 350 into 10 to the power 3, but we want in kilowatt. So 10 power 3 refers to kilo, or you can divide by 1000. So it will become 350 kilowatt. 34,500. Okay. If you got like 34,500, no, 345,000. Okay. 345,000 is there. When you convert into kilowatt, you will divide by 1000. So this will become 345 kilowatt or 350 rounded off. Usually marking scheme answers are rounded off, but you can say this is 345 kilowatt. Is it clear? Discussion? So next session we'll do more from this exercise, work, energy, and power.